Hello and good morning, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Introduction to Networks course based on the CompTIA Net Plus curriculum. And this tutorial is going to be your Worksheet 5 or your Unit 5 worksheet IP subnetting tutorial and answer key. So let's go ahead and dig in here. We've got about 4 pages to go through. Now remember, when we're dealing with subnetting, we need to make sure that we have a firm grasp on powers of 2, right? And let's change our color here. Let's go with red. So you can see that 2 to the 1 is 2, 2 to the 2 is 4, that the number simply doubles each time the exponent is raised by 1. So from 16 to 32, and we've worked through these before in class. And this is going to become extremely important when we start to look at subnetting. So let's clear the screen there. And again, as the exponent increases by 1, the decimal double value. So here are the 5 subnetting questions, and I really like the way that Todd Lamley lays out his subnetting tutorial. So you're basically asking yourself these 5 simple questions to answer everything that you would need to know. So how many subnets are created? Well, it'll be 2 to the x, where x is the number of bits that are changed from 0 to 1. And you hear me refer to this as also as borrowed. So how many host bits, which initially were a 0, do we borrow to change to network bits or subnet bits? That is what goes here. That's the exponent. How many valid hosts per subnet? Well, we look at this as 2 to the y, and the y is simply the number of host bits that remain after you've executed the subnetting part, right? So once you've borrowed the host bits, you're going to have a certain number of host bits left over, and those bits will be your y value. And we're going to see some examples here in a second. So then, what are the valid subnet addresses? Now, remember, it's being referred to here as the subnet address. We can also refer to it as the subnet ID, and that is based off this concept called the block size. Now, we're going to see there's 2 ways that we can get to the block size. The first is we could simply take 2 to the y, right? 2 to the y is going to give me my block size. Or when you're looking at the subnet mask in binary, you simply take the rightmost 1 bit, the rightmost bit that is in the on position, and the value of that bit position is also the block size. So I'll show you both ways to do that. Because really the key is if you can get the block size, you can pretty much figure out everything that you're going to need to know about subnetting. All right, so what is the broadcast address? Well, that is simply the next subnet minus 1, but minus 1 from the next block size. So if my block size was 64, I would start with subnet 0, and then 64, and then 128, and then 192. And so the subnet, when it says next subnet minus 1, so that's the next subnet, so my broadcast address would be .63. And over here, for this, we've got 4 networks here. For this network, it would be .127. Again, 1 minus the next subnet ID. And then .191, and then this would be .255. Because remember, we cannot go up to 256. So if I added 64 to this, it would take us to 256, but we can't go to 256, so we end at 255. And then what are the valid hosts or the assignable host IPs that can be used? Well, those would be all the IPs that fall in the range of .1 to .62. And that's where you end up with that 2 to the x minus, or I'm saying, how are they doing it here? So 2 to the y minus 2, and the 2 we're subtracting are the subnet ID and the broadcast address, because those are reserved. We can't assign those to hosts because they are needed for other uses. All right, let's clear the screen off here, and let's clear it off one more time. All right, so let's scroll down. So always build your subnet mask in binary first, then convert to the decimal notation. So in the example that we see here, this is where you're going to see the two different ways to come up with the block size. Let's turn our pin on here. So this would be the Class C IP address. Well, if it's a Class C, we know that the default mask is going to be a /24. And you can see right here, the first 24 bits are indicated as network bits. So we would say a /24. Now, the last 8 bits, these are my host bits. So with a /24, I have 2 to the 8 minus 2 usable IPs, and that's going to be 254. So there's 254 assignable IPs, or usable IPs, that I could assign to printers, I could assign to PCs, MacBooks. So we have 254. So the question that a lot of learners will ask is, well then, why? I don't understand. Why do I need to subnet? Because there's no big deal with me having all these extra addresses. Maybe you only need 10 addresses. So the reason behind subnetting was initially to try to conserve IP space and to right size. And what we mean by right size is create subnets that are more reflective of the requirements based off the host count, right? So in this example here, let's take a look here. So we've borrowed, right, or changed the first 2 host bits here into network bits. So now in dotted decimal notation, it's not 255.255.255.0, which is what it was with the /24. It's 255, 255, 255, and then look at those two values, right? Remember that leftmost value is 128, 2 to the 7. And then this one here is 2 to the 6, which is going to be 64. Sorry about that, which is 64. So 128 plus 64 gives us the 192. Now, we've borrowed 2 host bits, which means for me to figure the block size out, it's very simple. I simply look at the rightmost borrowed bit, and what is the value of that bit position? 64. Boom, there is your block size. The other way that you can do it, and the way that I typically do it, is I just take the number of host bits that are left, and it's 1, 2, 3, 4, 5, 6, and 2 to the 6 is 64. Because then the next question, right, is how many usable host IPs? Well, it's 2 to the 6 minus 2, so then we already know it's 62. That's very, very easy math right there. So I've got my block size, right? I know my number of usable host IPs, and that's the other way you can figure your block size out. Now, how many subnets will be created? Well, that's based off the number of subnet bits. So here we have 2 subnet bits. So 2 to the 2 equals 4. And these are the questions that make it, you ask yourself these 5 questions and it becomes very, very easy to sort out what the subnets are going to look like. So as soon as you get your block size, right? I mean, literally, if you wrote the subnet mask out in binary, right? Calculated it in decimal and then wrote it out in binary, you would get the block size immediately. And once you have the block size, you simply start at 0. That's my first network. And then increase by 64. There's my second network. Here's my third network. And it just so happens, remember, 2 to the 2, we borrowed those 2 bits. There is my fourth network. Remember, if I added 64 again, we'd end up at 256, like we just saw. You can't have that. So we end at the maximum number that we can see when we're doing dealing with bits in the octet is 255. So now it becomes very elementary. So what is the broadcast address here? It's going to be 1 less than the next subnet ID. And then this again, 127. and this one here, 191. So this is my subnet ID, or my network identifier. This is my broadcast address. And now, what are the usable host IPs? So let's change the color up here a little bit. So the usable host IPs will be from .1 to .62. Over here, it's .65. It's just the IPs in between the network ID and the broadcast address. 129 to 190. 193 to 254. So now I've created 4 smaller networks, because maybe I don't need 254 usable host IPs. Maybe the maximum number of users I'm ever going to have is going to be 60. And so we would end up with 62 usable host IPs, and that's going to be enough, right? So that's where, if you need to conserve your address space, you would end up subnetting, taking a larger /24 and breaking it into 4 by, what would the CIDR notation be here? Exactly, 24, 25, 26. So I end up with 4/26 networks. And this could be your HR, and this could be marketing, and this may be engineering, and this may be, what do we have? I can't think of another one. Finance, whatever, right? This may be the finance department. So, but once you get the block size, it makes it really, really easy to simply start with your .0, churn out by the block size all of the network IDs, and as soon as you would add and get to 256, you stop. And then you bound that at 255, right? And so there's the subnet addresses. Again, broadcast one less, so let's go ahead, let's clear that off, and let's clear that off there. And let's scroll down a little bit more. And again, for me, it's all about getting that block size, right? And remember, 255 is always last, and there are your valid host IPs. So now it's going to be up to us. So now we're going to step in, and we've got no help here. So the question I always like to answer first, again, for me, it's all about the block size, because once you nail the block size down, it's game over. It is literally game over. And so let's take a look at that. Very simple. So here is my Class C address. So we're dealing with 198.19.53.0. And so this is the subnet ID, right? The default mask is a /24. So before we do anything, if you're told that the new subnet mask is going to be a /27, or you're told that this is your subnet ID, write it out in the binary. Make the first 27 bits all ones, and then it comes down to this guy right here. What is the value of that rightmost borrowed subnet bit? Well, we've got 128, we've got 64, and then we have 32. So my block size, which I have just locked in, is 32. And at this point, that's it. All you have to do now is basic math, adding by 32. So I would start with .0. Subnet 2 is going to be .32. Subnet 3 is going to be .64. Subnet 5 is going to be .96. Or I'm sorry, subnet, let's make sure I keep these on track here. Subnet 3, 64. Subnet 4, 96. I add 32 to that, I'm going to get 128. Add 32 to that, I'm going to get 160. And then 7, they're down here, but we'll just go ahead and say subnet 7 is going to be .192. Subnet 8, subnet 8, not .8. So subnet 8, we would just simply add 32 to that, and we're going to get 224. And then subnet 9 is what? Add 32 to this, and I get 256. Nope. Above 255, we're done. So I get 8 subnets. Now, how can we easily check that? So I ended up with 8 subnets. I've got my block sizes. So I've got 3 borrowed bits. Well, remember, the number of subnets is 2 raised to the power of the number of subnet bits that have been borrowed. So 2 to the 3 is 8. And it just so happens that we, using the block size, ran ourselves all the way up to 8 subnets. I'll get rid of that 32 there. Ran ourselves up to 8 subnets. So new subnet mask creates how many? 8 subnets, because it's 2 to the 3 equals 8. Each subnet has, and now we simply count out the number of remaining host bits. So 1, 2, 3, 4, 5. So 2 to the 5 is 32 minus 2 is 30. And so that's going to give us the number of usable host IP addresses. It's 30. And we've already got the block size. Again, remember, if you can get the subnet mask either in CIDR notation or dotted decimal, all you have to do is get that into binary, and you've got your block size. And once you've got the block size, again, you just add for the network IDs by the block size. Start at 0, plus 32, 32, 64, 96, 128, 160, 192, 224. Done. And then all you'd need to do, and let me go ahead and clear this right now, all you would need to do once you get the .0, the .32, the .64, .96, is you write them out like this, .128, .160, .192, .224. And once you write them out like this, do you see how easy it becomes now to determine what is what? So what's the broadcast address here for this first network, for subnet 1? Well, it's going to be 1 less than the network ID of the following subnet. So .31, .63, .95, .127, .159, .191, .223, and then .255. So then my usable host IPs, again, you can see this starts to become elementary at this point. .1 up to .30. So there are my 30 usable, and by usable, remember what we're saying is I could assign this to a printer, or a MacBook, or a server, or a PC. .33 to .62. There's my 30 usable IPs in this subnet. Then we've got .65 to .94. Now, you may be noticing some things here. And remember this, when you're checking yourselves, remember, the broadcast address is always an odd number. 31, 63, 95, 7, 9, 1, 3, 5. And you know what? I don't know if that holds true, but I just realized that, do you see what's happening here? 1, 3, 5, 7, 9. 1, 3, 5. That would be interesting to see if that holds true, that pattern right there. I have never noticed that before. So that's very interesting. So we're going to do another subnet here real quick after we finish this one up, because I want to see if that holds true, because if it does, that's an interesting way to be able to check yourself. So, but again, the broadcast address is always odd. It's an odd number every time. Your network ID, what do you notice about that? It's always an even number. It'll never be an odd number. And the broadcast address will never be an odd number. So just another way to check yourself. So then you've got .97 to .126, .129 to .158, .161 to .190, .193 to .222, and .225 to .254. And so here are my usable host IPs. And I like to say the assignable, because you can assign these to nodes on each of these network segments. Okay, so that takes care of the /27 that we just saw. So let's spice things up a bit here. Let me scroll down a little bit, and I think that takes care of everything. Oh, so they wanted us to actually to fill this in. So let's make sure we. Oops, sorry. Let's make sure they've got it here twice. Is that right? Or am I seeing that backwards? 19.53. Fill in the subnets first and the broadcast addresses. Oh, okay. So subnet address, broadcast address. So yeah, we did that, but for completeness, let's do it again. So remember, go up by 32. So 32, 64, 96, 128. Get those dots in there. 192. Dot 2. Did I count this wrong? 32, 64, 96, 128. 160. Sorry about that. 160, 192, and then 224. Sorry about that. So there are your subnet IDs. And again, they all start with 198.19.53. So the broadcast address, again, is just one shy of the next subnet ID. So 63, 95, and again, so we just walk through these. So that should be pretty clear. And then we also, we also wrote out the valid IP addresses, right? We had those ranges from .1 to .30, from .33 to .62. So again, we wrote those out already kind of up above. So let's go to the whiteboard here because I want to take a look at something else which I thought was interesting. So let's say that we have 192.168.1.0/24. So again, in dotted decimal notation, a /24 is pretty easy. 1, 2, 3, 4, 5, 6, 7, 8. Not dotted decimal, sorry, binary. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my 24, and then the last 8 bits are going to be 2, 3, 4, my host bits. Now, let's say that we want to subnet this network, and we're going to need 16 subnets. So we would borrow 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 gives me 16. So I would borrow those 3 bits. As soon as I do that, my new value is 255, and so here's the dotted decimal, 255.255.255 dot 128 plus 64 plus 32 plus 16. Well, that's going to give me 192, 224. So 128 and 64 is 192, plus 32 is 224, plus 16 is 240. Now remember, this is how I would highly recommend you attack these problems. As soon as you figure out the CIDR notation, or you see the subnet mask in dotted decimal, or you see the subnet mask in binary, again, it's game over right here. What is the rightmost bit that has been borrowed? What is the value of the rightmost 1 bit that we have used to borrow from the host bits? The value is 16. And what is so critically important about that value? Exactly. That is my block size. And as soon as you get your block size, it is game over, because I'm going to go ahead and say, all right, we're going to start at .0. And then I would have .16. And I just go up by the block size. The network IDs increase by the block size. 48.64.80.96 and this one always bothers me, is it 112? Yeah, .112, .128, .144, we go up by 16 again, .160, we go up by 16 again, 176, and 192, and then I may have to actually, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We may squeeze it in here. So then add 16 to that. And we're going to get, is that 208? Is that right? Yeah, 208 and then 224, and then we add 16 to 224 gives me 240. And if I add 16 to 240, what do we get? We get 256. So we know that is the last subnet ID. And so again, you can see you're done. You're done, right? Because at this point, all of the binary, all of that tricky math becomes elementary. So I always like to draw lines in between the networks. And I want to see if that broadcast pattern holds up, because I thought that was interesting. So let's see if that pattern holds up. So here are my 16 subnets, right? And what's the broadcast address going to be here? Exactly, one less than the next network ID. So .15, .31, yeah, 5.1, it doesn't hold up. It just happened to be that way in the previous one. 47.63, .79, .95, .111. And again, always odd numbers. .127, .143, .159. Again, one less than the next .175. Then the next subnet ID, .191, .207, .223, .239, .255, the last and highest value that we can have. And so we've created how many subnets here? Well, how many bits were borrowed? 4. 2 to the 4 is 16. There are my 16 subnets. Now, how many usable IPs? Well, that's easy too. How many host bits remain? 4. So 2 to the number of remaining host bits minus 2 is 14. Because 2 to the 4 is 16, minus 2 is 14. So it would be .1 to .14. And there's your 14 usable IPs for network 1. .17 to .30. There's your 14 usable IPs for network 2. .33 to .46. There are my 14 usable IPs for network 3, and so on, right? Again, the key is to try to figure the block size out. Now, Jennifer asked a great question during class. She said, well, sometimes it's confusing. Sometimes I see an IP address like 192.168.1. And let's say, how are we going to work this out? So 32. So I'll just say 37. And then they show the CIDR notation right after it. And we'll use a /27 here. And then you get asked the question, what is the broadcast address and what is the network ID for the network in which this IP sits, this usable IP here, right? Well, again, it's already game over, right? Here is my CIDR notation. So /27 is 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. That's 24. Let's change colors here to make it a little more dramatic. 25, 26, 27, meaning the host bits I have left, what is that? 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4. 1, 2, 3, 4. Yep. So here are the remaining host bits, but what's the most important thing that we've already locked down here? You have already locked down the block size, because the block size is going to be the value of the rightmost bit position that has been borrowed. So 128, 64, 32. So if I know that my block size is 32, we're done here. Start at 0, .0, .32, and I can stop right there, because the usable IP that I'm being shown is greater than this network ID, but less than that network ID. And what would be my broadcast address here? Well, it would be 63. So where would .37 fall? He would fall right in this network, because the usables are going to be .33 to .62. So if you're asked what is the network ID and broadcast address, get that block size and then start laying it out until you hit a network ID that is greater than the IP you're being shown. Okay? Again, the block size is very critical here, and it makes it so easy to lay your subnetting information out. And then if you were asked what is the subnet mask in dotted decimal, well, it would be 255, right? Because our subnet mask is here in binary. We convert to decimal. We get 255.255.255 dot my 3 borrowed bits. 128 plus 64 is 192 plus 32 is 224. And again, the values that you will consistently see, remember in subnetting, when you're borrowing the bits, you're going from left to right. You can't come down here and say, oh, I want to borrow this bit here and this bit here, and then leave these guys as zeros. It has to be from left to right. So what are the only possible subnet values that you would ever see? It's either going to be .0 or .128 if the first bit has been borrowed. This is your default here. We're talking Class C. 128 if the first bit is borrowed. If you borrow the first and second bits, remember, you can't jump around. So if you're borrowing the first one and you need to borrow the second one, you're borrowing both the first and the second. So then it's going to go up to plus 64, 192. And then it goes up by 32, 224. And then it goes up by 16, 240. And then it goes up by 8, 248. And then it goes up by, I lost my place, by 4, 252. And then it goes up by 2, 254. And then it goes up by 1, the final one, 255, right? So that is it. In a subnet mask and dotted decimal, you are going to end up in the scenarios that we're working with here with this Class C stuff, as well as with Class B, you're going to end up with one of these values for your subnet mask. So definitely familiarize yourself with these values, and it's simply just taking the first bit and adding the second bit, and then adding the third bit, and then adding the fourth bit, and the fifth, and the sixth, and the seventh, and then finally the eighth. Now, we don't talk about these two here, right? And that would be a /31 and a /32. The important thing to note is that they exist, right? But it's going to be out. This is outside, a little more advanced and outside the scope of our course. But know that these do exist. So you can end up with a subnet mask that looks like this in dotted decimal, 255.255.255.255 or .254. And again, the 254 being the /31 and the 255 being the /32. So you can have subnet masks with both of these. However, we sort of end right there at a /30, right? Okay, so this is going to conclude sort of the supplemental tutorial here on subnetting. We walked through the worksheet, and again, remember, get that block size. If you can figure the block size out, you remove all of the nasty math from the equation. All right, guys, thanks for watching. Excellent job on the worksheets that were submitted this week, and I will see you all Tuesday night.